Hi everyone, so in this video we're going to take a quick look at the latest iteration of the CellDEVS simulation viewer here from the ARS lab, and primarily what we've added is support for layers, so you can do your classical 3D models, as well as support for multiple ports coming out of the Lopez simulator. In addition to that, we've added just a bunch of UI enhancements. Previous versions were mostly sort of a tech demo, proof of concept type of thing, that we can do this in the browser and it can be cross-platform and be very performant. And now we've shifted towards maybe more usability and having everything self-explanatory in a way. All right, so before I move on to demo, the features, two major limitations to keep in mind is that you can't have more than one model in the same log file. So if you have a coupled model with multiple atomic simulation results in the same log file, you're going to see something on the screen, but it's not going to be correct. The other thing is we only support 2D and 3D layers at the moment. Alright, so 4D and ND layers are coming down in the future. Alright, so just a reminder of how to load files. You can just drag them onto here. I'm just going to grab the color palette, a log file, and the model source. We're going to load the simulation. We're going to see this really clever and nice maze solving algorithm simulated right into the browser. And you'll see that it detected the port out. Now if you look at a more involved example, one that has a lot of ports, we'll see as the simulation loads, you're gonna see the layers pop up here. Alright, so these are all the layers involved in this simulation, and if I play it back, you'll see how they're each doing something slightly different. Right? The main layer is the one that's meant to be visualized, because it's essentially describing how pedestrians move. The other layers, the other ports, are basically functional ports. Things like when an elevator opens, what effect does that have on the field around crowd movement, and also general movement patterns for people heading to the west or people heading to the east, and so on. So there's a lot of ports here that I'm not interested in visualizing, so I'll just scroll back up and turn them off. Right. And I can just keep the ones that I'm interested in. Now I'm interested in these four, but I don't want to display them like this, so I can just add more column and have a better layout. And of course I can zoom in to any level I want, and you'll notice that the timeline player stays with me no matter where I zoom in. Okay, and so that was ports. So right now this is a 2D model still. This is not a 3D model. This is a 2D model that has multiple ports. So one of the other things you can do is you can actually play a 3D model. And in the current version of this software, it will still just display them as 2D layers, 2D slices. But down the road, we're working on advanced 3D simulations of those results. So I'm going to take an example here. I'm going to grab my color palette and a initial values, model, and a log. All right, I'm going to load the simulation. Now what you'll see here, if you'll notice on the right, we have multiple layers, and each layer has its own set of ports. So right now, each layer has only one port out. But you can imagine if you had a 3D model with multiple ports each. Alright, so I'm going to disable values because we're not interested in that, and disable the grid overlays, and zoom out a little bit, and put them together in a three column layout, and play that out. So this is a neat simulation that's creating sort of cool patterns. Here's another one, and we'll see what that looks like. You'll notice here that I didn't change any of the other ones, so I didn't need to load them again. So I just dragged a new log and played it right away. zoom out a little bit here. All right, play that back. Perfect. Now you can, of course, increase the frame rate if you wanted to, and it will attempt to play as fast as it can. But let's say you wanted to record this as a video, right? And your recording is not going as fast as you intended, but the video outcome will be as fast as whatever you set it to be here in your frame rate. So let's watch that. You'll see how smooth it is because it's playing back at 30 frames per second. Right? It's no longer computing it, it's now a video file that actually you can download, right? And play in VLC or even play in your browser itself. Right? Now, this feature itself is still just only supported on Chrome. We're working on alternatives down the line, but for now it's only it's solely a Chrome feature. But it's very useful to it's so easy to just share it on YouTube as well, because YouTube accepts this format. Now the last thing I wanted to show you is how this works on Android. So the simulation, the website works on Chrome and Firefox and IE. Chrome has the best experience in our view, but in terms of this application, and this also translates to mobile. So here I have my Nexus 5, and I'm just going to open up Chrome. I have the website loaded here, and I'm going to follow basically the same procedure. So I'm just going to load a couple of models that I have. So I've downloaded these from before, and of course, being on your mobile, you can access files on your Dropbox and so on. So it can be completely cloud-based. You don't have to actually carry around all these files with you. So opening up a val file, simulation log, and finally the color palette. And again, the order independent completely. It doesn't matter which order you select them in. And right there, we have a simulation running on your phone. All right, with all the features working. And this just goes to show that visualization as an end product, something that you can share with clients and domain experts, doesn't have to be on the same simulation backend, the main computer that you're using to do all your fancy calculations. If you're meeting with someone like a client or a domain expert, just take out your phone or tablet and show them the results live. So this was a quick overview of the new features. I hope you found it useful, and don't feel shy about giving us feedback. If you wanted to look at more models like that, just head on to our samples database. A lot of stuff that was done over the years at the ARS lab, and we're happy to share it with anyone. Thanks.